Who the math? Who the math? Who the math? Who the math?
Plus, sign, multiply, subtract, and divide. Get math in your mind, then you'll see your dollars rise. Teachers, have your kids play video games, cause it helps to get the math facts into the brain. Simple and plain, we educate with minimal strain. Have fun, everybody now, isn't it great? Try some long division today, we just give it away. No time limits, you can...
Alright. We're in video 42.
We are. I got my TI 84. I'm ready for business. Let's do it.
Okay. So, today we're using our kind of descriptive variables to create a linear regression model, figuring out slope and y-intercept.
Right. This is how our calculator does it. There are actually formulas for calculating A and B. So sometimes you're not giving the data in the problem or a computer printout. You're giving statistics about the x variable, the y variable, and the correlation. So if you look at these formulas, there's actually 5 statistics you need. To calculate the slope, B, you need R, the standard deviation of the y variable, and the standard deviation of the x variable. Then to calculate the y-intercept, you need B, so you gotta find B first.
Yep.
And then you need the mean of the x and the mean of the y. So there are 5 data items involved. But usually it's pretty straightforward once you realize this kind of problem. They're giving you the statistics, put it together in the formulas, find A and B, and then you can write the regression equation.
Exactly.
All right.
Alright, let's put it to use. So, here we're giving Olympic long jumps and high jumps displayed in a scatter plot. Well, we don't have the scatter plot, but it did give us both the mean and standard deviation of both long jump and high jump.
Right, and if it's a linear model, it's a pretty strong one because correlation is 0.917.
I'm going to guess this is displayed in inches.
Long jump?
Because if that's feet, that's like Superman.
Like your college days?
Yeah, right. All right, so we need to write the equation for the line of regression. So first we need to find our slope. So we have B. All right, so we're given...
Well, let's write the formula equals R times SY
times S of Y
over SX.
X.
How do I know it? I've just seen it so many times.
Okay, so we're estimating high jump from long jump. So these are our Y's. This is our X.
Okay.
All right, so mean of the, so our R, sorry,
It's 0.917.
0.917
Okay.
times S of Y, well, that's the high jump, that's 7.26 divided by 20.71.
Mr. Lewis, I feel like we're really getting inside the calculator's mind here.
Yes,
A dangerous place, probably. Divided by
20.71.
And we get B is 0.321.
0.321. That is a 3.
Okay.
There we go.
Now, wow. We need some space for A.
A. So here's A. So here, just
Okay. A is Y
Equals
bar.
Y bar. So that would be 83. 0, 4. Well, I don't know why I did a dash. That's supposed to be a point.
Okay.
Minus.
Minus.
Oh, I am just like all over the place. Here, plus negative.
B, which
B.
is 0.321.
321. 0, 321 times
X bar.
314.1.
Okay. 83.04
Yes.
minus
Minus.
0.321
Mm-hmm.
times X bar, which was 314.1.
Yes.
We get negative 17.8.
17.8.
Now, let's write the equation for the line of best fit.
Yes.
The best would be to use the names of the variables, but let's keep it short. Y hat
Okay. Y hat
equals
equals
negative 17.8, because that was A
8
plus BX.
plus 0.321 x.
Very good.
Bam.
All right, now, once we have that, we're back where we always are. We have
Yes.
a line of best fit. So the slope is 0.321, and let's write in the units.
3, 2, 1
And-
inches.
Inches per inch. So it's
Per-
inches over inches, because it's inches high jump over inches long jump.
Yes.
Okay, now, we're just going to say verbally how to interpret the slope. So as usual, on average, we're going to use the words on average.
Yes.
For each additional inch of long jump, they can jump 0.321 inches higher.
Right.
That's what the data is saying.
Mhm.
Okay. All right. So we just wrote the slope and the units, inches per inches, but we got to practice writing that sentence about what it means.
Yes.
Okay. In a year, when the long jump is 340 inches, what high jump would you predict? So we got to use our line of best fit.
Yeah. So we do our y hat equals negative 17.8 plus 0.321 times 340, because our x is our long jump. Always go slower.
All right.
on
Negative
the bottom.
17.8 plus 0.321 times 340,
Yes.
91.34. So that's based on their long jump. That's what we predict their high jump is. Wow, it's so hard to write with that pen. Okay,
Go
so
slow.
just to
All right.
review. So we got a lot of stuff here. We use formulas to calculate A and B
Yes,
instead
we
of getting it from our calculator. So it's a matter of just plugging in,
Mm-hmm.
recognizing what the data is. I think the key part here is you mark that X and that Y.
Yes.
So some things, it's not necessarily obvious. You got to think which statistics belong to the X variable, which belong to the Y. But once you realize that, you're just plugging into the equations. You get your line of best fit, then you can do all the usual stuff.
Right.
Okay, let's see one more example. Here we go. So the relationship between the price of yachts, I'll never have to worry about the price of a yacht, I gotta be honest, and their length X is analyzed. The average length was 47 feet and standard deviation of 10. So the length is X. So we're going to record our information as we go along.
Yeah.
So right here, Mr. Lewis, can you put X bar?
Yes. X bar equals
47.
47.
That's what that first fact was. And the standard deviation of 10 was S sub X equals 10. Then it says the mean price was 87,000. That's Y bar. This price is what we're predicting with standard deviation of 14,000. And we need one more thing. We need all this stuff. Then the correlation R is 0.39. Now, we just have to calculate the, well, first we always calculate the slope.
Right.
Because the y-intercept involves the slope. So let's write the formula for slope. B equals, I always like to write the formula when in stats or algebra or whatever. I always like to kind of write the formula I'm using over Sx. And so that's going to equal 0.39 times 14,000 divided by 10.
Mm-hmm.
And the slope is 546.
Now,
And I'm going to throw in units real quick. That would be dollars per foot. So even though I didn't ask, always be thinking, what does this mean?
right.
So for each additional foot, on average, your yacht's going to cost you $546 more.
Yes. And now, if this was a test problem, you can already kind of answer this problem, because here they give you the equations. Well, this is the only one with slope of 546. But let's just check that we found the right y-intercept. by
Yeah, let's
plugging it
check
in.
their math, man.
Yeah.
So let's write the formula. A equals
Equals
y bar
y bar
minus b times x bar. And then we can substitute in. That would be 14,000 minus 546.
Yeah, you might as well do it because this
Times
is going to go really
47.
slow.
I think you have an old man pen there.
For some reason, when it gets to the
You got my
bottom,
pen.
it is super, super slow.
All right,
All right.
it is.
I'm going to guess
It's even slower than me. It's negative 11,662. What?
Wait a minute.
What?
What did we do wrong? Oh, I know why. This is supposed to be 87,000.
Oh, good point. Sorry about that. Did I do that?
I think you did.
I feel like Urkel. Did I do that? 87,000. Sorry about that. That's why we do math together, man.
Yes. So that when one
It
of
comes
us-
out to 61,338, which rounds to 61,300.
Right.
So the difference is rounding. Okay. It's always nice to know the answer ahead of time before you do the
does.
work.
Then you're like, wait a second.
That's math, man. Beautiful.
Right. That backs up.
All right. I'm glad we found something to slow Mr. Lewis down here. All right.
All right. Here we go. Oop. Looks like we're doing one more.
Okay. We'll try to be fast about this one. Relationship between the number of games won by a minor league baseball team, they're nice enough to say that was X, and the average attendance Y. The mean number of games, so X bar is 66, and SX is 17. The mean attendance was 6,177, so that's Y bar. And the standard deviation is 1480.
Oops. There's no 7 there.
67.
Sorry. That's just 6177.
Okay, standard deviation.
Supply is, sorry, 1480.
Good. And R is 0.46. Kind of a weak pattern, right?
Yes.
Okay.
A little stronger than the last one, but still kind of weak.
Okay. So we'll take the shortcut. If we can solve it by just finding B, we will.
Yeah.
So that's kind of nice. All of the slopes are different. So if we find the slope, we're good. So B equals
B equals
R times SY over SX.
okay. So
0.46
0.46.
times 1480, is it? Yeah.
Yes. 1480.
Divided by 17. Yeah. Is 40.04. Mr. Lewis,
40.04.
we have a winner.
Is it the same letter we did the last time?
E.
Yes, it is.
I'm going to start guessing
E.
E everywhere. Now, we could go and verify that the value of A, just use the formula for A.
Mm-hmm.
All right. Let's hit it.
Okay. Oh, it's your guys' turn.
Wow.
Okay, so now we have winner in the city. Appropriate for
Yeah.
what's
today.
going on. So we have latitude and January temperatures. So we want you to write the equation of the line of regression for estimating the January temperature based on the latitude.
Okay.
Then interpret the slope. And then figure out if I gave you a latitude of 23, what would you predict the January temperature?
Good question. Which one's the X variable?
I don't know. Should we let them figure that out?
I guess so.
I think you guys should figure that out. Because otherwise, it's super easy after that.
Okay, so use the formulas, and so you may have to go back in a few frames and see the formulas. But use the formulas to write the equation of the regression line. You're going to interpret the slope. Should say on average something something something.
Yep.
And then make a prediction.
All right.
Super.
See you guys later.
Yep.